Hello again, Pharmates. Let's talk about the history of the atom. The atom is the smallest unit of material into which matter can be divided without the release of electrically charged particles. Known as the basic building block of chemistry, the atom has the characteristic properties of a chemical element. The atomic theory of the universe was first developed by Democritus. He theorized that all material bodies are made up of invisible small particles called atoms. Atomos is the Greek word meaning not to be cut or not to be divided. John Dalton is best known for his pioneering theory of atomism. He also developed methods of calculate atomic weights and structures and formulated the law of partial pressures. Because Dalton thought atoms were the smallest particles of matter, he envisioned them as solid, hard, indestructible spheres, like billiard balls, so he used wooden balls to model them. In the billiard ball model, Dalton added that the model atoms could be joined together with hooks and used to model compounds. He was disproven when subatomic particles were discovered, namely the electron, proton, and neutron. In 1897, J. Thompson discovered the electron by experimenting with a cathode ray tube. He demonstrated that cathode rays were negatively charged. An electron is a negatively charged subatomic particle. It can either be free or not attached to any atom, or bound to the nucleus of an atom. Electrons in atoms exist in spherical shells of several radii, representing energy levels. The larger spherical shell, the higher the energy contained in the electron. Along with the discovery of electron, J. Thomson developed an atomic model known as the plum pudding model or the raisin bread model, as each atom was a sphere filled with positively charged fluid known as the pudding. Scattered in this fluid were negatively charged electrons. These were the plums in the pudding. A proton is one of the three main particles that make up the atom. It is found in the nucleus. It has an electrical charge of +1 and a mass of 1 atomic mass unit. Atoms of any given element have a unique number of protons that is different from the number of protons of all other elements. The proton was discovered by Ernest Rutherford in the early 1900s. During this period, his research resulted in a nuclear reaction which led to the first splitting of the atom, where he discovered the protons. He named his discovery protons based on the Greek word protos, which means first. The Rutherford gold foil experiment shot minute particles at a thin sheet of gold. It was found that a small percentage of the particles were deflected, which a majority passed through the sheet. This caused Rutherford to conclude that mostly empty space with a tiny dense positively charged nucleus, the mass of an atom, was concentrated at its center. Based on these results, Rutherford proposed the nuclear model of the atom. In 1932, the physicist James Chadwick conducted an experiment in which he bombarded beryllium with alpha particles from the natural radioactive decay of polonium. The resulting radiation showed high penetration through a lead shield, which could not be explained via particles known at the time. A neutron is a subatomic particle with no net electrostatic charge, with a very similar mass to a proton. Neutrons are present in almost all atomic nuclei, except hydrogen. Niels Bohr proposed a model of the atom in which the electron was able to occupy only certain orbits around the nucleus. This atomic model was the first to use quantum theory, in that the electrons are limited to the specific orbits around the nucleus. The Bohr model shows that the electrons in the atoms are in orbits of differing energy around the nucleus. Think of planets orbiting around the Sun. Erwin Schrodinger showed that the quantization of the hydrogen atom's energy levels that appeared in Niels Bohr's atomic model could be calculated from the Schrodinger equation, which describes how the wave function of a quantum mechanical system, in this case a hydrogen atom's electron, evolves. The Schrodinger wave equation replaced Bohr's ideas about the electron location with an uncertain factor. The location of the electron can only be given as a probability that the electron is somewhere in a certain area. Thanks for watching this video. Please share, like, and subscribe, and see you